Okay, so here we have a question from DC machine. It's actually very simple and it's based on simple resistance formulas. If you understand the connection of lap winding and wave winding, it's actually very easy to solve. Before we move to the solution, I want you to pause the video and try it yourself first. Okay. Now, how do you calculate the number of conductors? So we all know that the DC machine or any machine normally are in shape of a cylinder. Okay. Now, if you take a conductor and if you connect the conductor like this, so like on the DC machine, 1, 2, 3, 4, like this. Okay. So this is complete one conductor, but since the way you have put the conductor on the machine, here we will count it as 4 conductors. How? So this is one, this is one, this is one, this is one. This is how we count the number of conductors. Okay. So now if I take another length and do like this, so now it is total 4 plus 4, that will be 8 conductors. Okay. And number of parallel path, that will be 2. Parallel path 2. As you can see here, it is 1, I'll take 1 and it is coming out on this side, and there is a number 2 coming out this side. So there's 2 parallel path and 8 conductors. All right. Now moving to the next part. So in this question we have 480 conductors. All right. Now if the length of the machine is L, then total length of the conductor will be 480 into L unit, that means centimeter, meter, millimeter, whatever. So I'm writing unit only. Okay. So total length of the conductor is 480 into L. Now if we have 2 parallel paths, then each parallel path will be of, like, what will be the length? That will be 480 by 480 into L by 2 unit. That will be the length of each parallel path. Okay. So 2 parallel path, when this is for what? This is for wave winding. Yes. Now in case of lap winding, number of parallel path is equal to number of poles. So in this case, each parallel path length will be, length of each parallel path will be 480 into L by P unit. I hope it is clear so far. Now, what is the formula of resistance? Normal formula that we have studied in class 10 or 12th. Okay. So formula is, we know that resistance R is equal to rho into L upon A. Okay. So here R is the resistance, rho is the resistivity, L is the length, and A is the cross section area of the conductor. So since we are not changing the cross section, we are not changing the conductor, so the A will be constant, rho also will be constant. Okay, we are just changing the L. So can I say resistance R is proportional to L, or I write length. And also when we connect same resistance in parallel, the equivalent resistance become R by 2 here. Actually the 2 is the number of resistance. So if I connect R, 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 3 resistance, then the equivalent resistance will become R upon 3. So you can consider this as parallel path, just like our machine case. Okay, so we can also say that resistance R is proportional to, inversely proportional to the parallel path. Fine. So if I combine these two relations, we will get that resistance R is proportional to the length by parallel path. Now we are going to use this formula in this question now. Okay, so in the first case, if I just take the ratio, that will be better. So R wave by R lap, let's take ratio. Then length, what is the length? We have already calculated the length, that is 480 upon 480 into L by P and 480 into L by 2. So that will be, I'll just write the formula again. Length of wave winding, length of lap winding into parallel path of lap by parallel path of wave. I hope it is clear. So now I can, R wave, the resistance given is 0. How much? 0.54, right? And lap winding is 0.06. Length of the wave, so that will be 480 into L by 2 and length of 480 into L by P into parallel path of lap, that will be pole, number of pole, and parallel path of wave is 2, right? So if you calculate this side, you get 9 is equal to 480 into L will cut, so you'll get P by 2 into P by 2. So P square is equal to 36 and P is equal to 6. So this is your final answer. I hope you have understood the problem, how to solve this. But in case of any competitive exam, you will not get this much time to solve a problem. Okay, so there you have to remember this relation here. So if you check, see this one and this one, if you solve this, you will actually get that resistance is actually inversely proportional to the number of parallel path square, number of parallel path square. Okay, so see, that's why we're getting, if you solve this, you'll get R wave divided by R lap. You will get, in case of wave, the number of parallel path is 2, and in case of lap, number of parallel path is P, so we'll get this. So R wave we know 0.54, 0.06, that will be equal to P square by See, we are getting this relation directly here. But you have to remember here, actually the number of conductor has to be same. If the number of conductor changes, then we will not be using this formula. So number of conductors and also the length of machine, these two has to be constant. Okay, then only we can use this formula or this actually. Okay, I'll just highlight this, so that will save a lot of time. Okay, thank you so much. So still if you have any question and doubt or regarding any other topic also, you can ask me in the comment section. I will definitely answer those. Okay, thank you for watching. Have a good day.